For millennia, Saturn has captivated humanity. Its majestic rings a cosmic halo in our night sky. A symbol of constancy, a jewel among planets, it seems eternal. Yet, the universe is anything but static. Recent observations reveal a secret. Even this ancient gas giant, once considered unchanging, is undergoing profound transformations, hinting at a dynamic future. This documentary delves into the surprising story of Saturn's metamorphosis. From its shrinking core to its shifting rings and the enigmatic storms that rage across its surface, we will explore the forces at play. What hidden mechanisms drive these changes, and what do they tell us about the life cycle of gas giants and perhaps our own solar system? For centuries, astronomers believed they understood the ringed jewel of our solar system. However, cutting-edge missions like Cassini have unveiled a planet far more dynamic and unpredictable than imagined. Prepare to witness Saturn as never before, a world in constant flux, challenging our perceptions and rewriting the cosmic narrative of stability. Saturn, the sixth planet from the Sun, is a magnificent gas giant, second only to Jupiter in size. Composed primarily of hydrogen and helium, it lacks a solid surface, instead featuring a swirling vortex of gases that gradually condense into a liquid metallic core. Its immense scale dwarfs Earth, a true behemoth among celestial bodies. But it's Saturn's iconic ring system that truly sets it apart. Stretching hundreds of thousands of kilometers, yet remarkably thin, these shimmering structures are a cosmic spectacle. For centuries, their very existence puzzled scientists, igniting curiosity and driving generations of astronomical observation. They remain one of the solar system's most enduring mysteries. These rings are not solid, but rather countless billions of ice particles, dust, and rock, ranging in size from microscopic grains to mountains. Each particle orbits Saturn independently, creating a delicate dance held together by gravity. Understanding their behavior is key to unlocking many of Saturn's secrets, including its ongoing transformations. Early astronomers, peering through rudimentary telescopes, first glimpsed Saturn's peculiar appendages. Galileo Galilei in 1610 described them as handles or ears, unable to discern their true nature. His observations marked the dawn of our detailed exploration of the solar system, challenging ancient geocentric views. It wasn't until Christian Huygens in 1655, with a more powerful telescope, that the true ring structure was identified. He famously declared, "It is surrounded by a thin, flat ring, nowhere touching." This groundbreaking discovery forever changed our understanding of planetary architecture, revealing the solar system's exquisite complexity. For centuries thereafter, ground-based observatories continued to monitor Saturn, cataloging its moons and charting the subtle movements of its atmosphere. These persistent efforts built a foundation of knowledge, allowing scientists to track changes over time, paving the way for the sophisticated space missions that would eventually revolutionize our understanding. The true era of Saturn exploration began with the Voyager missions in the early 1980s. These intrepid probes offered humanity its first close-up, breathtaking views of Saturn's rings and its diverse family of moons. Voyager images unveiled a planet far more intricate and dynamic than any telescope on Earth could ever reveal. However, it was the Cassini-Huygens mission arriving in 2004 that truly transformed our perception of Saturn. For over 13 years, Cassini orbited the planet, sending back an unprecedented wealth of data, imagery, and scientific insights. Its prolonged gaze allowed for the detailed study of Saturn's evolving nature. Cassini's instruments peered deep into Saturn's atmosphere, analyzed its ring system in exquisite detail, and explored its numerous moons. The mission dramatically expanded our understanding of planetary processes, revealing a complex, active world. It was Cassini that truly showed us a Saturn that is anything but static. Saturn's atmosphere is a chaotic symphony of powerful winds and colossal storms. Jet streams, moving at incredible speeds, carve distinct bands across its surface, creating a visual tapestry of browns, yellows, and oranges. These atmospheric features, however, are not constant. They shift, evolve, and sometimes erupt with surprising intensity. One of Saturn's most baffling features is the colossal hexagonal storm at its north pole, first observed by Voyager and later meticulously studied by Cassini. This six-sided jet stream, wider than Earth, has persisted for decades, a stable anomaly in a turbulent world. Its origins and long-term stability remain subjects of intense scientific inquiry. Beyond the hexagon, massive great white spots periodically erupt, vast hurricane-like storms that can encircle the entire planet. These events, occurring roughly every 20 to 30 Earth years, dramatically alter Saturn's appearance and atmospheric dynamics. Scientists believe these outbursts are driven by deep internal convection. Saturn's rings, far from being static, are a dynamic, ever-changing system. Gravitational interactions with Saturn's moons, collisions between ring particles, and the influence of solar radiation all contribute to their constant evolution. They are a cosmic laboratory of orbital mechanics in action, always subtly rearranging themselves. Within the broader ring system, distinct divisions and intricate patterns emerge. The Cassini division, a prominent gap, is maintained by the moon Mimas, which clears a path with its gravitational resonance. Other moonlets embedded within the rings create propeller-shaped gaps, silent testimonies to ongoing sculpting processes. Scientists have also observed spokes, dark, transient features that appear across the B ring, believed to be microscopic dust particles temporarily lifted out of the ring plane by electrostatic forces. These fleeting phenomena underscore the ring's constant activity and sensitivity to the surrounding space environment. Saturn is accompanied by a vast retinue of moons, over 80 confirmed, each a unique world contributing to the planet's intricate dynamics. From the massive, hazy Titan to the tiny, icy Enceladus, these satellites exert gravitational influence, shaping not only the rings but potentially Saturn itself. Titan, Saturn's largest moon, is unique in our solar system for having a dense atmosphere and stable bodies of liquid on its surface, not water, but methane and ethane. Its active weather system, complete with clouds and rain, makes it a fascinating analogue to early Earth, constantly reshaping its terrain. Enceladus, though much smaller, holds an even more profound secret: a subsurface ocean of liquid water beneath its icy shell. Geysers erupt from its south pole, spewing water vapor and organic molecules into space, making it a prime candidate in the search for extraterrestrial life and a potent influencer on the E-ring. The gravitational dance between Saturn and its many moons is a perpetual ballet of forces. These interactions sculpt the rings, induce tidal heating within the moons themselves, and even subtly affect Saturn's internal structure. This complex web of influence is integral to understanding the planet's ongoing dynamic evolution. Beyond the gravitational ballet, Saturn's most iconic feature, its rings, are themselves a canvas of constant change. Once thought to be ancient and immutable, observations reveal a dynamic system where material shifts, clumps form, and subtle patterns emerge and fade. Unraveling these transformations is key to understanding the rings' enigmatic past and their eventual fate. One perplexing phenomenon is the appearance of spokes, radial patterns of dust that momentarily stretch across the rings. These transient features, appearing and disappearing over hours, defy simple gravitational explanations. Scientists believe electromagnetic forces, potentially influenced by Saturn's magnetic field, are responsible, but the precise mechanism remains an active area of research and debate. The F-ring, Saturn's outermost narrow ring, presents another captivating mystery: its braided and knotted structure. This intricate weaving is attributed to the gravitational influence of its two shepherd moons, Prometheus and Pandora. Their close passes and orbital resonances pull and sculpt the ring particles, demonstrating the delicate yet powerful interactions shaping Saturn's majestic system. Perhaps the greatest conflict surrounding the rings is their age. For decades, it was assumed they were as old as Saturn itself, billions of years. However, new evidence from Cassini, including their pristine composition and estimated mass, suggests a much younger age, possibly only tens or hundreds of millions of years. This dramatically shifts our understanding of their origin. If the rings are young, how did they form? One prevailing theory posits a relatively recent event, a comet or asteroid shattering a small icy moon of Saturn, its fragments dispersing into orbit. Another suggests two smaller moons collided. These catastrophic scenarios imply Saturn's ring system, as we know it, is a temporary, albeit grand, phenomenon in cosmic time. Cassini's grand finale offered unprecedented close-up views revealing tiny, intricate structures and propeller features within the rings caused by unseen moonlets. These observations provided crucial data, allowing scientists to refine models of ring dynamics and understand the ongoing process of aggregation and fragmentation. Every detail tells a story of constant, cosmic remodeling. Saturn's moons are not mere passive observers, they are powerful agents of change. Their gravitational tugs not only sculpt the rings, but also induce orbital migrations, causing moons to slowly move closer or further from Saturn over eons. This dance of attraction and repulsion continuously reshapes the entire Saturnian system, making it a living, breathing entity. Among Saturn's diverse retinue, Enceladus stands out as a world of profound mystery and revelation. Initially appearing as a small, icy sphere, Cassini's instruments uncovered an astonishing secret: a vast, subsurface ocean of liquid water beneath its south pole. This discovery instantly transformed Enceladus into one of the most compelling targets in the search for extraterrestrial life. The ocean's existence was confirmed by powerful geysers erupting from tiger stripes, fractures near the South Pole, spewing water vapor and organic molecules into space. This plume provides direct access to Enceladus's hidden depths, allowing scientists to sample its composition and assess its habitability. The continuous outflow signifies an active, dynamic internal process. The source of Enceladus's internal heat, crucial for maintaining its liquid ocean, is tidal flexing. Saturn's immense gravity needs the moon as it orbits, generating friction that melts ice deep within. This constant energy input makes Enceladus a prime candidate for hydrothermal vents on its seafloor, similar to those that support life on Earth without sunlight. Further out, Titan, Saturn's largest moon, presents a radically different yet equally captivating world. Enveloped in a thick, hazy atmosphere, Titan is the only moon in our solar system with a substantial atmosphere. It's a complex, nitrogen-rich blanket, denser than Earth's, completely obscuring its surface from visible light, posing a profound mystery for early explorers. Beneath Titan's shrouded skies lies a landscape sculpted by methane. Radar mapping by Cassini's Huygens probe revealed vast lakes and rivers of liquid methane and ethane forming a hydrological cycle remarkably similar to Earth's water cycle. This alien chemistry challenges our definitions of ocean and rain, providing a unique laboratory for studying planetary processes. Titan also displays evidence of cryovolcanism, where icy magma, composed of water and ammonia, erupts onto its surface. This suggests internal heat and geological activity, further complicating its already intricate planetary geology. The constant interaction between its atmosphere, surface, and interior makes Titan a continuously evolving world of incredible complexity. Mimas, another small icy moon, offers a different kind of mystery. Famous for its Herschel crater, giving it a Death Star appearance, Mimas's internal structure has puzzled scientists. Data suggests it might harbor a subsurface ocean, or perhaps an oddly shaped, highly eccentric core. Both scenarios challenge current moon formation models and demand further investigation. Iapetus, Saturn's two-toned moon, presents an enigma of its own. One hemisphere is dark, the other bright, with a mysterious equatorial ridge that makes it appear like a giant walnut. Scientists believe the dark material is accumulated dust from another moon, Phoebe, but the origin of the ridge, hinting at past geological activity, remains a subject of intense scientific debate. Saturn itself is far from static. Its dynamic atmosphere hosts colossal storms, dwarfing any tempest on Earth. Every few decades, a great white spot erupts, a planet-girdling storm visible even from Earth through telescopes. These atmospheric events are expressions of Saturn's deep internal energy and its constantly churning, turbulent gas layers. At Saturn's North Pole, an extraordinary and enduring mystery persists, a hexagonal jet stream thousands of kilometers wide. This stable, six-sided pattern, unique in the solar system, is a high-altitude atmospheric wave, likely formed by powerful convective currents deep within the planet. Its persistence and geometric perfection continue to fascinate and challenge fluid dynamicists. Like Earth, Saturn experiences spectacular aurorae, shimmering lights at its poles, generated by interactions between its magnetic field and the solar wind. However, Saturn's auroras are often more complex and dynamic, influenced by its rapid rotation and the plasma generated by its moons. Studying them provides insights into Saturn's magnetic field and its atmospheric composition. Saturn's long orbital period means its seasons last for years, causing dramatic shifts in its atmospheric conditions. These seasonal changes affect cloud patterns, storm activity, and even the appearance of its rings. Understanding how Saturn's atmosphere responds to these monumental seasonal forcing is critical to comprehending gas giant climate systems. Saturn radiates more energy than it receives from the Sun, implying a powerful internal heat source. Scientists believe this excess heat comes from gravitational contraction and a process called helium rain, where helium separates from hydrogen deep within the planet and sinks towards the core. This slow, continuous process fuels Saturn's dynamism and internal heat. The precise nature of Saturn's core remains a profound mystery. Is it a dense, rocky silicate core, or a more diffuse, fuzzy core of heavier elements mixed with hydrogen and helium? Gravitational data from Cassini suggests a larger, more spread-out core than previously thought, challenging existing models of gas, giant formation and evolution. This enigma continues to drive research. Scientists grapple with these contradictions daily. Data from various instruments often presents conflicting narratives, pushing the boundaries of our understanding. Each new piece of information, from ring particle composition to subtle gravitational anomalies, forces a re-evaluation of established theories. It's a painstaking process of elimination and refinement, a true scientific detective story. To bridge these knowledge gaps, sophisticated computer models are indispensable. Researchers simulate Saturn's atmosphere, ring dynamics, and internal processes, testing hypotheses against real-world observations. These digital laboratories allow for exploration of scenarios impossible to witness directly, providing crucial insights into the forces that shape this complex world. Cassini's grand finale in 2017, plunging into Saturn's atmosphere, provided a final, invaluable dataset. Before its fiery end, it directly sampled Saturn's upper atmosphere, measured its gravitational and magnetic fields with unprecedented precision, offering critical clues about its internal structure and the mass of its rings. It was a heroic final act. Despite decades of exploration, Saturn still holds many secrets. Future missions, perhaps with orbiters capable of ring-grazing maneuvers or probes designed to sample moon plumes more extensively, will be necessary. Scientists are also planning instruments to better understand its magnetosphere and the complex interactions with its numerous, enigmatic moons. The revelations about Saturn's dynamic nature teach us a fundamental truth. The cosmos is never static. From its shifting rings to its churning atmosphere, from geysering moons to its mysterious core, Saturn is a world in perpetual flux. It's a profound reminder that even the most familiar celestial bodies harbor endless wonders and enduring mysteries. Our journey through Saturn's ever-changing realm has peeled back layers of cosmic assumption. We've witnessed a giant world in constant flux, from the subtle dance of its ring particles to the colossal storms scarring its clouds. This dynamism isn't merely an intriguing feature, it's a profound testament to the active, evolving nature of all celestial bodies. This newfound understanding of Saturn's evolution reshapes our very theories of planet formation and longevity. If a gas giant as seemingly stable as Saturn can undergo such dramatic transformations, what does that imply for younger, more turbulent worlds? It challenges us to look beyond static images and embrace the universe's inherent fluidity. The implications stretch far beyond our solar system, influencing how we interpret data from distant exoplanets. When we observe a world orbiting another star, knowing Saturn's intricate changes helps scientists predict potential atmospheric shifts or ring structures we might otherwise overlook. It adds crucial context to the vast tapestry of extrasolar discovery. Saturn's secrets remind us that our cosmic neighborhood is anything but a fixed landscape. It's a living, breathing laboratory, revealing the universal processes that sculpt galaxies, stars, and planets alike. Our planet, too, is a product of these relentless forces, making our connection to Saturn's story deeply personal and profound. The quest to understand Saturn is far from over. Each new observation, every refined model, opens more questions than answers, propelling scientists forward into uncharted territory. It's a continuous dialogue between humanity's curiosity and the cosmos's boundless enigmas, a pursuit that enriches our collective understanding of existence itself. This relentless human drive to explore, to question, and to comprehend the universe around us is perhaps the most remarkable aspect of this entire endeavor. It's the spirit that built spacecraft like Cassini, that fueled generations of astronomers, and that continues to push the boundaries of what we deem possible to know about the cosmos. The beauty of scientific inquiry lies in its adaptability. As new data emerges from Saturn, our models evolve, sometimes drastically. This isn't a weakness, but a strength, a testament to science's commitment to truth, constantly refining our narratives to better reflect the universe's complexity, revealing deeper levels of wonder. Despite decades of observation, Saturn still guards many of its deepest secrets. The true nature of its core, the precise mechanisms driving its hexagonal jet stream, and the future fate of its magnificent rings remain areas of active research. These mysteries ensure that Saturn will continue to be a beacon for scientific fascination. Future missions, perhaps with advanced ring probes or atmospheric entry vehicles, promise to unlock even more of Saturn's enigmatic behavior. Ground-based telescopes and the James Webb Space Telescope will continue to provide invaluable, long-term observational data, building upon the legacy of pioneers like Cassini, pushing the frontiers of knowledge. What Saturn teaches us about change and evolution resonates across all gas giants. Jupiter's great red spot, Uranus's extreme tilt, Neptune's violent winds, each possesses dynamic secrets. Saturn's story provides a crucial Rosetta Stone, helping us decode the common threads and unique intricacies woven into the fabric of these colossal worlds. To gaze upon Saturn, even through the lens of a documentary, is to connect with something ancient and vast. It's a moment of profound cosmic perspective, reminding us of the intricate ballet of forces that shaped our universe and continue to shape it, constantly creating and recreating wonders far beyond our terrestrial comprehension. In essence, Saturn is not just a planet. It's a cosmic laboratory, an ongoing experiment playing out on an unimaginable scale. Its changes offer direct insights into the fundamental physics of gravity, fluid dynamics, and planetary thermodynamics. It is a classroom where the universe itself provides the lessons, if only we are willing to observe. So, as we conclude our journey, remember that Saturn, the jewel of our solar system, is not a static postcard, but a living, breathing entity. Its iconic rings are shifting, its atmosphere churns with surprising fury, and its moons harbor their own geological sagas, all telling a story of continuous, mesmerizing change. We've seen how Cassini's legacy redefined our understanding, revealing seasonal shifts, a changing ring system, and the active cryovolcanism of Enceladus. These discoveries highlight the imperative of long-duration missions and the value of patiently observing the cosmos to truly grasp its deep, enduring transformations over time. If Saturn's dynamic evolution has captivated your imagination, be sure to hit that like button, subscribe for more cosmic adventures, and let us know in the comments, what aspect of Saturn's change do you find most astonishing? Your engagement helps us continue exploring the universe's most incredible secrets. Next time, we'll turn our gaze to a world even more enigmatic, shrouded in mystery and tilted on its side, Uranus. What secrets does this distant ice giant hold, and how is it too undergoing its own unique transformations? Join us as we plunge into its strange, icy depths for another escapist documentary.